Today you're going to learn how to solve a quadratic equation using the product sum method. Here we have the equation 0 is equal to x squared plus 6x plus 8. Following the original equation, 0 is equal to ax squared plus bx plus c. So here 6 is b and 8 is c. Sorry, the x is not part of b. Okay, so in the product sum method, we want to find two numbers. Let's name them m and n. These two numbers are the magical numbers, okay? So the properties of these numbers are they should add up to m plus n equal to b, and the product of them should equal to c. So in this case, we know that 8 is equal to c, and we know that 6 is equal to b. So that means, in turn, m plus n is equal to 6, and m times n is equal to 8. Let's create a table. That's a good one. Okay, so the table. So product and sum. So the product is 8 and the sum is 6. So we have to find factors of 8 for the product. So let's list out the factor pairs of 8. 1, 8, 2, 4, and then 4, 2, 8, 1. They're the same. So a number that's under 6. 0, 6, 1, 5, 2, 4, 3, 3, and so on. So we want to find common factor pair between both of them so they can be the magic numbers. So I notice that 2, 4 is here and 2, 4 is here. So our magic numbers are 2 and 4. Doesn't matter in which order, so we'll call them m is equal to 2 and n is equal to 4. Okay, so now that we have the magic numbers, we can rewrite the quadratic equation like this. 0 is equal to x squared plus 2x plus 4x plus 8. And we can rewrite it like this because these two numbers, 2x and 4x, sum to 6x anyway. Okay, so then we now have two equations, x squared plus 2x, and then we're adding that to another equation, 4x plus 8. Okay, now we have to factor these. X squared plus 2x. What is the common factor in both of these numbers? I see x, so we can put x on the outside and we can put x plus 2, and then next one, 4x plus 8. The common factor is 4 because there's 4 in 4x and there's 4 in 8. So 4 times x plus 2, because 4x divided by 4 is x and 8 divided by 4 is 2. So now we have two equations that are factored. We can rewrite that from the original quadratic equation like this. Zero is equal to x times x plus 2 plus 4 times x plus 2. And we can rewrite this like 0 is equal to x plus 4 times x plus 2 because we're multiplying x and 4 by the same thing. So if we add x plus 4 and multiply that whole thing by x plus 2, it will get us the same result. So now we can equate x plus 4 or x plus 2, either of the equations, to 0. Because if x plus 4 is equal to 0, then anything times 0 is equal to 0. So x plus 2 can have any value, and then same vice versa. So let's equate x plus 4 is equal to 0, and then we have x plus 2 is equal to 0. Okay? So here, we can solve this using normal algebra. X is equal to minus 4, x is equal to minus 2. So the roots, or the solution, are minus 2, minus 4. On a graph, that would be, the point would be minus 2 comma 0 and minus 4 comma 0. These are our roots. Okay. Now let's have some example questions. Okay, so for the example questions, let's have 0 is equal to x squared plus 12x plus 35. Let's have 0 is equal to x squared plus 4x plus 3. And let's have 0 is equal to x squared minus 6x plus 9. Take a minute and solve them. You can pause the video. Okay, so now I'll get into the solutions. So here we see that we need two numbers that add up to 12 and multiply to 35. So if we make the table, I'm not going to do that right now, but if we make the table, we get the numbers as 7 and 5, because 7 times 5 is equal to 35, and 7 plus 5 is equal to 12. So our magic numbers m and n are equal to 7 and 5. So from there, we can just rewrite it as 0 is equal to x squared plus 7x plus 5x plus 35. Factor it, we get x times x plus 7 plus 5 times x plus 7. And then as our final equations, we get 0 is equal to x plus 7 times x plus 5. And same thing using algebra, we get the numbers as x, x, the eraser. I need the eraser, okay. Okay. We get x is equal to minus 5 and x is equal to minus 7. And on a graph, that would be minus 7, 0. Oh, I'm going to the next question. Oops. Minus 7, 0, minus 5, 0. And those are our roots. Erase it. Okay, next question. Same thing. 3 times 1 is equal to 3. 3 plus 1 is equal to 4. 0 is equal to x squared plus 3x plus x plus 3. factor that, we get x times x plus 3. 1 times x plus 3. Final equations are x plus 1 times x plus 3. Using algebra, we get x equal to minus 1, x is equal to minus 3. And then on the graph, that would be minus 1, 0, and minus 3, 0. Those are our roots. Okay, now last equation. This one's a bit different. It has a negative. Mostly the same, but it's different. Okay, I'm going to use blue this time. So, two numbers, 3 times 3 is equal to 9 if you make a table. And then we get, oh, 3 plus 3 is equal to 6, but it says minus 6. So we have to find two numbers that equal to, or multiply to 9, but are also negative. So we can do the same thing, except we can do minus 3 times minus 3 equal to 9, because minus times minus is plus. So minus 3 is equal to minus 6. So we got our magic numbers. They are minus 3 and minus 3. So now rewrite it, x squared, use green, plus green, x squared, plus, oh, it's not, okay, it's minus. No. One sec, technical difficulties. Okay, there. X squared minus 3x minus 3x minus 3x. Okay, x squared minus 3x minus 3x. Oh god. Sorry, my whiteboard's really lagging. Get that over here. X squared minus 3x minus 3x plus 9. Okay, wait, just wait a moment. Oh, it seems as my whiteboard stopped working. Okay, so I'll just do it orally. So we get x squared minus 3x minus 3x is plus 9. We factor it. Oh, now it works. Okay, yeah, we got it. Sorry, it's a bit messy now. So x squared minus 3x minus 3x plus 9. We can create two equations, x times x minus 3, minus 3 times x plus 3. Our two equations are x minus 3 times x minus 3, or just x minus 3 whole squared. On a graph, that will look like minus 3 zeros as our only solution. And that's it.